For you to go on a ride to space, the launch vehicle ride is not small. You go through a lot of vibration, and the vibration is probably several times of what you experience on any of the toughest rides here on ground, right?
Speaking about investors who are backing your company, would you be able to name?
One of the names that may be very familiar is the. If two satellites collide with each other, they break into hundreds of parts. And each one of them is traveling at few kilometers per second, and it acts like a bullet.
Yeah.
That kind of acts as a chain reaction, hits another satellite. In order to avoid that, each country is the space agencies like NASA or the European Space Agencies originally were using a toxic fuel called hydrogen. We wanted to use water as a fuel for the first time. So Elon Musk started increasing the launch cadence. I think today he can even launch like 2 to 3 rockets a week. Seen recently the beautiful landing and capture of SpaceX boosters, and you had robotic arms which precisely caught them.
Like chopsticks.
It was,
of-
yeah, the chopstick one.
Yeah.
It was a beauty, and it was indeed a work of AI as well.
Does AI have a place in space tech?
Well,
Hello and welcome to a new episode of Tech Talks. I'm Vandana Nair, Senior Tech Journalist at AIM Media House. Today I have with me the co-founder and COO of space tech company Bellatrix Aerospace. Hello Yashas Karanam, welcome to Tech Talks.
thank you for having me here.
Yeah, how are you feeling today?
All good, it's a busy day.
All right, I want to dive right into how did this begin? How did Bellatrix begin? Can you tell me a bit about why this name? I mean, if you go by Harry Potter, I'm pretty sure that's not what you had in mind. But yeah, please go ahead.
Well, I think I'll start off with the second part. Of course, it's not named after the Harry Potter character. It's a very interesting star in the Orion constellation. In fact, it's known to be a star where there could be active star-forming region. So I think the goal was, as a propulsion company, Bellatrix, we wanted to be the company which does this kind of interstellar travel technologies which could propel humans to such distant locations. That was the vision. It could not happen right now, maybe 150 years down the line. But we want Bellatrix to be that company which is able to do that. And the company started out as mostly as a college project. In fact, my other colleague and Rohan, who is the CEO, along with Sagar, Rajesh, Vivek, a couple of other friends in college, they all started working on a project called Microwave Plasma Thruster, where we wanted to develop an engine for satellites. It's an electric engine, something like EV revolution in space. Okay. Where we wanted to use water as a fuel for the first time. We wanted to replace toxic fuels. We wanted to replace expensive gases which were currently used in the industry. Replace that with water. So that's how the journey started out. And the success of this project as a college project drove us to let out actually our dreams of probably going to Ivy League universities or delving further into academia, getting PhDs, and rather focusing that on business and building a brand and building a company which could actually make all this.
Okay. So can you tell me which year it started and what has been the journey since the beginning?
So the company officially started in 2015, but as a team, I think Rohan and team started out in 2012. I came in 2013. And overall, I think it's been a phenomenal journey of almost 13 years. And always, I think we see that when somebody's starting out something new, trying to do something fresh, I think the number of challenges are generally high. I think the same case with us when we started out. I think we were one of the first companies who had to build our own products in India, whereas most of the space companies around that time were mostly building or manufacturing technologies as per ISRO's design and manufacturing it for ISRO. So we only had to look at these examples and rather look at global examples, try building something for our own, build our own complete product line, and not only look at Indian market, but also get a global overview, try to sell it to the global market. So we brought all of those into perception and tried building the company around a global picture.
Okay. So if you're taking that approach, that would involve a lot of cost and a lot of capital, right? If you're going from the scratch.
Yeah, there is a funny saying, space industry is a sinkhole for money. More the money you deploy, more it goes into capital, more it goes into R&D. So you have to keep investing more and more into the industry is the common saying. But at least for our case, right, we have definitely invested quite a bit. There's more to invest, but we have kind of come to a point of R&D where I think a lot of technologies are developed in-house.
Mhm.
So rather than going the approach of buying a lot of subcomponents, building them here in India, I think we realized it makes sense for us to build almost all the things we make in-house, starting from the subsystem level.
Okay.
So if you're looking at a typical space company, the way it works is, say, if I were to build a propulsion system, I could rather go buy a valve from a company which actually makes valves, go buy propellant from a propellant manufacturing company, buy catalyst from, say, Shell or Sabic or some of these, Globe, and then assemble all of them, test and sell the thing as a system. But we realized if we are doing that for each and every component, and our suppliers are outside India, and we had to like import everything, pay shipping duty, custom duty, all of that, it would not make sense on a long term. So I think we were blessed with a really capable team. The team was very passionate to build everything from scratch. And also we had several retired ISRO scientists who were advising us on this.
Okay.
So with all of this as a support ecosystem, we took a bold decision to build even materials in-house.
Okay.
A lot of things have been indigenized.
So when it comes to say in-house, if you're building everything, then even what about sourcing of the raw materials and those kind? I mean, are there challenges in that?
So somehow we are not facing any of the challenges with raw materials, at least also because the main critical things which might get into problems with importing are all done in-house.
Okay.
Say, for example, if you're talking of a guidance navigation system, the algorithms and the hardware for that, for example, are built in-house for us. So these kinds of things are generally the ones that could possibly used in dual use applications. So these are generally done here. So we have not got into such issues.
Okay. And you transitioned from making launch vehicles to propulsion engines, right? So why that move? And have you ever thought that, okay, is this the right thing to do?
Well, I think we thought that 100 times before we decided to do that. And the reason actually we shifted from launch vehicles to in-space propulsion, not shifted. I think we had both the models, but I think we wanted to zero in on propulsion systems more, put all the effort here, is because I think the global industry started to change. So when we looked at launch vehicles as a market, we realized I think there was a demand for launch vehicles which could put payload into orbit very quickly. Time was a challenge because for the larger launch vehicles, launch frequency was probably 2 rockets a year or something like that. And for you to get an orbit of your preference, say you're building a 200 kilogram satellite, for you to choose the orbit, it was not possible because a launch vehicle would have a capacity of over a ton. Say Elon Musk SpaceX has a capacity of up to 9-10 tons. And you cannot decide which orbit it goes because you're only sending a 200 kg platform. So for you to actually get your satellite into a precise orbit you want, you have to wait for a primary customer, say a 4-ton class satellite, which goes to an orbit like that.
Okay.
So until then, if you're waiting, a lot of times the wait time itself was about 3 years. So there was a demand for precise launch, right? But I think what changed, and the reason we also changed our model, was the launch frequency started to increase. So Elon Musk started increasing the launch cadence. I think today he can even launch like 2 to 3 rockets a week. Right, that's the kind of capacity he has gotten, and that trend had started. And recovery and reuse of launch stages, that also was a major thing. And because Elon Musk is doing it, that also challenged all the existing rocket companies to also fast track their processes. So if the launch cadence actually improved and people were able to launch faster with the bigger rockets, it always made sense to go with the bigger ones.
Okay.
So it's like going for a chartered flight versus a traditional flight, right? So if you are super rich and if you only want to go in a chartered flight, you would do it. Otherwise, I think you would probably go with a business class on a normal flight, right? So something like that. So we felt this could not work out on a long term, especially because of the increased launch cadence. And economics of scale also come in. If you're doing something with a big launch vehicle, I think the costs usually come down because per kilogram costs generally come down. But of course, there are companies which are trying to figure out different models to make the small rockets work. I'm not saying that is false, because I think Rocket Lab is still doing a good business. But we felt, at least for Bellatrix, it was a wiser decision that way.
Got it. And can you explain the process of, say, if a Bellatrix product has to get into space, like what are the steps?
So to send anything to space, it's a long drawn process, right? For example, with Bellatrix here, we are working on propulsion technology, and at the time when we started, we were the only ones in the country who were working on a few things that we were. Right, ISRO of course had been doing it. They really know their stuff, and ISRO had been doing it for some of the larger satellites. We wanted to initially tackle the same challenge for the low Earth orbit satellites and the small and micro satellites. So we started working on high performance green propulsion. We wanted to replace toxic and carcinogenic fuels used in space with greener high performance alternatives. So that was one we wanted to develop. And here, if I had to develop it, there was no expertise in the country for this.
Okay.
So we had to reinvent the wheel. In fact, we also collaborated with a professor from Indian Institute of Science who also helped us with some of the things here. So it kind of started off there. Similarly, with electric propulsion, it was even more challenging because Rohan, Rajesh, and the team had to actually do the whole thing themselves and burn a lot of hardware, put a lot of effort into reinventing the wheel. The Russians originally did it, but the know-how was very closely guarded. Just to give you a sense of how complex this would be, right? You have to convert a matter into a plasma state, which is like the fifth hottest state of matter. And the particles would go to temperatures of around 11,000 Kelvin, which is like twice as hot as sun's surface temperatures. And there are no known materials on Earth which can actually handle such temperatures. So it's a play of electromagnetics as to how you're operating the system safely and also efficiently generating thrust out of it.
Wow.
So I think the team actually mastered that, and there was nobody to actually tell us how it is done. So everything had to be learnt.
Yeah, that's correct.
So that was the approach. So once you do all the research here on ground, you have done a demonstration, but that is not enough to take it to space, because in space the conditions are really very different. You have, for example, you will have to negate the radiation levels that come in from solar cycles, from the sun, all of that, because here the atmosphere is protecting us, but in space it's a very different story. It's a very harsh environment in terms of radiation. And even in terms of thermal properties, a lot of times, if this is a satellite, I think one side you may be facing, like one side of the rotation you may be facing plus 120 degrees. On the other side, it might even go to minus 80, minus 100 degrees Celsius. So your thermals have to be ready for all of that. And for you to go on a ride to space, the launch vehicle ride is not smooth. You go through a lot of vibration, and the vibration is probably several times of what you experience on any of the toughest rides here on ground, right? So you'll have to design and qualify your systems, even the electronics, wiring, all of that have to qualify for this.
Okay.
So considering all of that, there is a ground qualification cycle and a space qualification cycle. And you also have to design all your systems so that they work in space flawlessly without any issue or without any repair person having to go there and repair things for the next 20 years. So build your system to be so robust that it goes through all of this. That has been the challenge.
Okay, got it. So you focus on green products, using green products or sustainable products. Like how did that begin?
Yeah. So I think it was a new opportunity for Bellatrix to enter a market which already had some incumbents, and some of the incumbents which actually built propulsion systems earlier. These were companies which had been in the business for the last 20 years, 30, 40 years. And the technologies they built or focused on were all for the large geostationary satellites. And it so happened that the space agencies like NASA or the European space agencies originally were using a toxic fuel called hydrazine.
Okay.
So all the industries continued on the same heritage because it's industry that does not quickly change in terms of toxicity or any of that. It's all performance linked and it's all value for money linked. So, and most important, it's a heritage linked business. So it did take a lot of time, but now since the industry started going from large geostationary satellites, just to give some perspective, one geostationary satellite would weigh upwards of 3 tons and would be size of a room, and it was very expensive. So from a constellation of large geostationary satellites, people started going to constellation of much bigger constellations of low Earth orbit satellites, and here each satellite would be about 100 kilograms or 200 kilograms. So the industry started changing, and that gave an opportunity for new entrants like us to come in and cater to a new market that got created, which the incumbent technologies did not solve completely. So when we were doing that, we saw that the toxic fuels were One, of course, there was a human impact. The people handling the fuel were on a risk of having cancer. And two, I think even in terms of storage handling, these were not friendly to store or transport. So a lot of times the filling activity was very expensive and time consuming. So we wanted to change that. And globally also there was a regulatory push. Europe has a program called REACH. Generally, it's a good thing we have to attribute to Europe. They're the first ones to recognize and act on climate change or any of the environmental impacts. So under REACH program, they put a ban on this toxic chemical called hydrazine and called out to the industries to shift to a greener propellant within the next 10 years.
Okay.
So now from 2022 onwards, Europe is now only mandated to use green propulsion. So that was also something we took in. Looking at all this, we thought if Bellatrix is now as a new entrant building a business, why do we have to go with the traditional toxic ones? We'll go with more efficient, greener fuels. That was with green propulsion. Again, electric propulsion is like, as I was saying, the EV revolution in space. Like here on ground, it's much more fuel efficient. So we also wanted to develop technologies which are more fuel efficient and which in turn would result in a bigger ROI for the customers. So with larger ROI, I think the impact is mostly driven back to the end user also. So the cost for the end user also comes down.
Got it. And like the Europe reach that you spoke about, is there like a specific ask levels in India, like any form of regulations or?
So it's under discussion, at least with the India's new policy. I think definitely not on the toxic fuel part right now, but I think there are definitely some measures under consideration to ensure you use the space sustainably. For example, one consideration under discussion is there are so many low Earth orbit satellites going out there, and there could be risk of certain debris collisions. Like when I say debris collisions, I mean if two satellites collide with each other, they break into hundreds of parts. And each one of them is traveling at few kilometers per second, and it acts like a bullet. That kind of acts as a chain reaction, hits another satellites, renders the space useless. This is called Kessler syndrome or Kessler effect.
Okay.
So, in order to avoid that, each country is taking responsibility of all the satellites that the respective country is launching and operating. So, if I'm an Indian country, I need to launch out of Indian soil, or I need to register the satellite through India. India would take the responsibility of ensuring that I'm using my satellite sustainably. So, there would be a back push on the policy side to ensure that you have a propulsion system which would avoid such collisions. So you can activate a propulsion system, outmaneuver, avoid the collision. And second, there is an important thing called deorbiting, which is a new regulation. In US, again, there is a body called FCC which grants licenses. They made a new mandate that every satellite going out there must have a mechanism to deorbit itself during the end of the life. What it means is when you're down to last 20% of your fuel, use your propulsion system to deorbit your satellite and clear that real estate for the next satellite to come. So I think these kinds of things are under discussion in India, and it could definitely come up sometime soon.
God. And when it deorbits, like what is the end result of it? Like how does it like get out of the system or something?
Yeah, that's an interesting question. If you're talking of a low Earth orbit satellite, so I'm talking of satellites which orbit between 500 to 700 kilometers, for example. You start turning your satellite towards the Earth and continue to orbit. So instead of raising an orbit like this, you start lowering your orbit. And once you come in contact with the Earth's atmosphere, because of all the air drag and friction that is a result of all of that, you start burning up and your satellite burns up in the atmosphere. That's generally how it happens. But if you're in the geostationary orbit, there is an orbit called graveyard orbit. So your satellite is moved there and it stays there for an indefinite period of time.
Fine. And correct me if I'm wrong. So now we have a lot of these low Earth orbit satellites for telecommunications and all that. And I think a lot of companies are getting into that space. So the situation that you explained, like whether you're going to have overly populated kind of satellite, is that something that can happen, or how do you prevent
something
that?
Still under control, because if you're looking at the vastness of space around that area, right? If you look at the Earth's diameter, it's itself huge. Now you're talking of say 700, 800 kilometers above that, which means your circumference is much bigger. But even then, there are chances of some debris satellite, maybe some defunct satellites still roaming around them. You can call them rogue satellites. They're fully out of control. What if one of those goes and hits an active satellite? So that is to be avoided. So what we have right now is a combination of ground-based telescopes and radars, which are looking at each of these satellites. And going forward, there are also companies which are trying to also build a network of satellites in space, which also monitor these debris right from space. So with that, you get a clear map of debris. And then once you know that, through ground stations, you just command your propulsion system to activate, and then you can avoid debris. So that way you just outmaneuver.
Okay. Yeah. Okay. And in terms of limitations and challenges, like what are the engineering challenges that you have in propulsion systems?
Well, I think any new technology in the space tech area does come with challenges, and propulsion is even more intense because you're dealing with either extremely challenging combustion challenges.
Yeah.
So our engineers are working not only at the simulation level but also at hardware level, where you're burning a lot of fuel and going through a lot of iterations of hardware. So that way, I think there's a challenge of optimization, and a lot of times in terms of materials, right?
Yeah.
You need to come up with the right material which can handle all these combustion parameters. That way, right processes. So there are challenges around identifying and building all of this, and especially if you're in India, you don't have an ecosystem, or maybe I don't have a company which probably is in the chemical domain which has this kind of expertise.
Yeah.
I'm just talking of chemical as an example. It would link to every domain that we touch upon. So that expertise is not there in the country. So we'll have to build all of those in-house. So Bellatrix is mostly a multidisciplinary team. We have people from all kinds of backgrounds, from nanoscience to plasma physics to different kinds of chemical studies, and of course all kinds of engineers here. So it's a mixed team which is solving all the things together. So that's one of the things. And if you're looking at electric propulsion, for example, sometimes it's a behavior of plasma, right? You don't know how plasma works. It's not well thoroughly studied, at least for these kinds of thrusters. So we'll have to work around a lot of electromagnetic challenges there.
Got it. So my question, does AI have a place in space tech?
Well, of course, AI is something now picking up. In fact, now there are missions where you cannot continuously keep monitoring a satellite from ground.
Yeah.
You need some sort of autonomous navigation. A lot of times, there could be situations where there are certain satellites which might require service. Just with that, like you can send a service satellite from one point to go there, do some service, and come back. For all of these, since satellites are moving at extremely high velocities and you have limited ground stations, and the distance of satellites is very high, you can't always uplink and downlink within a fraction of seconds. It takes time for you to also do that. So you can't do all the operations with ground handling, or you call it telecommand and telemetry from ground. So you can't do everything, process here, or let a human actually decide what to do and send a command. So far, a lot of missions have done that, but with these kinds of new applications coming up, that would be a challenge. So what would actually come in is, what if your AI can use some sensors, detect where these target satellites are, where you want to service them, or there is an option to even refuel satellites. So can your AI determine, map, navigate, and also do the operations right there at the satellite where you need to do these operations? Take all decisions in space, just give the data to Earth that this is done. This could be one example. And similarly, in terms of optimization of signal flow, there is something called inter-satellite link happening. So can we also map within the constellation, which is your nearest satellite, and try to optimize the size of data that goes down? And now there is also one thing called edge computing, which is coming up. Yeah. So with edge computing, a lot of processing, digital like decision making, or even sampling of data, all of that happens in space. So can your neural networks actually determine what data to be kept, what decision to be taken, and what minimal data has to be downlinked to ground? So these are some things which can come up, and especially because the data sizes are huge and ground station window is limited and your satellite passes very quickly, these can be optimized with AI. These are like just the initial applications. Going forward, I think people are thinking of a lot of other things. And I forgot to mention about the launch vehicle side of things, right? You might have read or seen recently the beautiful landing and capture of SpaceX boosters.
Yes.
And it's a massive like few thousand ton worth of, size of boosters. Those actually came down, and they also came to the launch pad where you could actually capture it. and you had robotic arms which precisely caught them.
Like
It
chopsticks.
was,
is
yeah,
what they
the
say,
chopstick one.
right? Yeah.
It's called the Mechasilla arm, right? It was a beauty and it was indeed a work of AI as well.
Okay.
So all these are really interesting challenges that people are solving. And yeah, I think there are a lot of other applications. Even if you're looking at simulation, like combustion challenges, there could be a lot of simulations which could be enhanced with AI.
Okay.
So these are interesting.
So the simulation bit, is it like the digital twin building? Like a
So
replica?
there are works going on here. I think the technology is not yet that mature, but you could definitely get to that point sometime.
And at Bellatrix, how much of it is used, like AI models or anything that you
We
can
have
talk
a AI team. It's called AI for Space. That's
Okay.
a team within Bellatrix. I think we are building on some of the applications I spoke to you about.
Yeah.
So as a propulsion company, it is always responsible to have a mechanism to prepare for future missions like that, where you need service, fueling, or something like that. So we are working on those kinds of readiness here.
Okay. And how important are collaborations with government agencies like ISRO, DRDO, and others?
So I would say at least our experience has been really good. We've been working with ISRO quite a lot, and in space, which is a newly formed entity, has also been helping us. In fact, our first contract came in from ISRO in 2016. And through that contract, it was not just a product that we gave to ISRO, but also a great experience where we saw how ISRO would itself qualify its system for space. So we got a chance to work hands in hands with ISRO scientists. They handholded us. They also kind of gave us all the quality requirements which ISRO itself uses. That was really helpful because we then built a complete process flow, manufacturing, and qualification cycle around how they want it. And ISRO's standards are generally at par with the global standards.
Okay.
So that was a good learning experience, at least for Bellatrix. And I feel it's definitely useful for any space company for that matter. And now with the new space policies, at least the facilities are opening up. So in Bellatrix case, since we were one of the older early entrants, we also built all the facilities in-house. It is useful for us because now we are in the production phase. So for production, it always makes sense if you have your facilities in-house. But for somebody who's in the early R&D cycle, unless you need something every day, you can still go use some of the ISRO facilities on play.
Got it. And in the last few years, at least, you've seen like a boost of these space tech companies. They're coming up. What kind of accelerated that, or what kind of started that?
So I think it has been picking up over the years, right? If you're looking at 2012, there was probably one company. 2015, there were 3 space companies. In 2017, 2018, I think it was up to 10 companies back then. But I think after 2019 or 2020, I think the acceleration has started significantly. It also has to do with how the government is really helping and supporting the industry. If you saw 2020 as part of the COVID package, which was like the 20 lakh crore package that Nirmala Sitharaman announced, a part of that was also opening up a new sector for increased employment and increased investments. Office space was one of the sector that the government actually opened. So after that happened, I think a lot more confidence came up with upcoming founders as well. So you had more people even quitting their ISRO jobs and coming up and starting up on their own because they now know that the government is supporting this sector. And India also kind of realized that we had, we were one of the top 5 global spacefaring nations. Quite a lot of times we were even like this third company to do something in space for the first time. So with all of that kind of capability also, India still had less than 2% of the global commercial market share. That was because only ISRO was doing everything and the industry was at the most supplying components to ISRO. So there was definitely a clear mismatch in what India was capable of and what we were extracting from a commercial or a business sense. So I think government realized and started emphasizing private companies to come up in a big way and build products around newer technologies in the space tech area, which could be marketable globally. So under that purview, I think a lot of companies have seen light of that. Investors have got more confidence, so more investment is flowing into the sector. I think all these have kick-started, and even with policy, earlier there was a lot of gray area around what the policy would be like. So we got a as first movers, I think Bellatrix and a couple of others who started out earlier, we had also been pushing government through various forums, various industry organizations, all of that on a new policy. And we happen to be on one of the first ones to have suggested these kinds of policies. So with all of that, I think the government has realized this, and a new policy has come up. And the policy is really supportive. So these have been the main things.
So you also interesting, you mentioned about how the movement from say ISRO employees, kind of having like being more ambitious now to have their own startup. So is that a trend that you foresee that will just keep
Not
increasing?
necessarily, right? That is part of the thing. So of course, somebody from ISRO might also do it. Likewise, some student might do it.
Okay.
Somebody who's working in a totally different industry can see a business opportunity here and still do it. That way, I think it is not limited to what former ISRO employees had done in their previous careers, because the opportunities are very different. It doesn't make sense for you to do exactly what ISRO was already doing and you were part of this project, right? So it's a change has to come.
Speaking about investors who are backing your company, would you be able to name and how is your relationship with them?
So I think we are fortunate to have really good investors, quite a lot of them. In fact, a couple of them that I can name off are, I think one is Inflexor.
Maybe.
And we also have Pavestone, Startup Exceed, and we have BASF, which is a German chemical giant.
Yeah.
And one of the names that may be very familiar is Deepika Padukone.
Yeah.
We have GrowX from Delhi. So
how did that
good
happen?
Set of investors.
How did Deepika get to?
I think she also had a lot of inclination to tech startups. Always wanted to support something of this sort where it's deep tech and of national interest. I think Bellatrix was a good fit for that.
Okay, got it. Going into the talent bit, like how do you perceive the talent space in India? Like say the emerging engineers or do they have the right infra to kind of be equipped to be working in a space tech startup?
Absolutely. I think the kind of education system that we are in, I think there are a lot of questions around that, but still I feel we are really good with what it takes to build a space company or space products, because the engineers we have got have been really good. And a lot of times training or onboarding onto particular technologies would be required, but everybody is a quick learner as far as we have seen. As long as somebody is passionate towards that field, they do whatever it takes to learn anything new and then onboard themselves onto that. So it's a definitely a good space, and we have not seen this just with some of the IITs or some of the creamiest of the colleges.
Mm-hmm.
But anybody with good project during their college, during even a normal college pass out, right? Even they are able to turn things around and do a lot.
Yeah. And what advice would you give aspiring students who would want to work in a space tech company in the future?
Well, I think if they're really serious about space, try to get a college project which is linked to the space industry. That would give them a deeper insight into what it takes to build something for space, and also a better exposure to do that. And always focus on more and more projects. Definitely practical experience is something that counts big time in the space industry. So serious projects, serious work, and some sort of inclination towards space industry is good. And space is not only open for aerospace engineers, but it's also open for people of all verticals. We would need mechanical engineers, electrical engineers. We would even need certain plasma engineers, nuclear engineers, nanophysics, different chemistry topics, even software engineers. As I was talking earlier, even AI in space is picking up. So there are a lot of topics which I think the space industry is recruiting big time. So all people can apply to the sector depending on the openings. They need not refrain themselves thinking that probably I'm a software engineer, I cannot apply to space.
And what about the notion that where students would say do their undergrad here and they'll kind of move out to do their postgrad and specialize and then probably work there? I mean, do you see a trend that's changing now? And do you see like students who want to stay back in India and build something here?
Yeah, absolutely. Now the opportunities are a bit better here in India because there are not just in space tech sector but also across, right? Even a lot in the software side as well. So there are really exciting challenges to solve within the country. You're getting a good space, and I think in terms of like the trade-off, right? Generally, people go there because of a better project opportunity. as well as better growth opportunity, and of course the financial incentives that are linked to it. So I think those are served here. And even like if you're really paid well, you could probably visit all those countries that you want to live in. So I think it makes a lot of sense to stay back here and build technology for the country here. The ecosystem has come up. And a lot of people who are also going out are coming back. So some of those applications are also coming to us for jobs. So that way, I think the system is getting better.
Good. And any interesting projects you're working on currently, and also what is your vision for 2025?
So we are working on several interesting projects on the propulsion front. As I was saying, we are doing green propulsion and electric propulsion. And next we are also working on an orbital transfer vehicle. So this is like a mothership satellite which is capable of carrying multiple small satellites and doing a Uber pool kind of a service in space. We take multiple satellites, drive them to the final destination. Rocket is like your flight from Bangalore to Delhi. And once you go to Delhi, we are like the Uber pool who will take you to the final destination. So that is one service that we are doing. And second, the fourth product line is something called ultra low Earth orbit satellites. It's a very interesting technology where I think we are bringing down satellites from the low Earth orbits even further lower to an orbit called ultra low Earth orbit. So this is about less than 250 kilometers in space. And as of today, no satellites operate there because you are entering the Earth's atmospheric region. And with atmosphere, you have drag, and this drag is going to pull your satellite down. So you can't keep your satellite for more than a few days. So we have done a breakthrough in propulsion technology, which is going to enable satellites to stay there for a very long period of time. I am talking of several years. So that is one breakthrough technology that Bellatrix is working on. And this time it's not just the propulsion system, but we are building the entire satellite around it.
Okay.
So with this, Bellatrix is a complete satellite solution provider.
And what is the advantage of that? The satellites being at even more.
So closer you are to Earth, the better your satellite is going to do its job. So if you are trying to do a imaging satellite, you are imaging Earth. If you are closer to an object, obviously you get an optical zoom. So instead of 600 kilometers, you are taking the same photo from 200 kilometers. So your images become one of the best from space. And the cost of your imager also comes down because instead of having a telescope, which is maybe, say, 800 in diameter, you could do the same thing in maybe the half the size of the telescope, which costs you much less. And similarly, if you're talking of communication satellites, your upcoming 60 communication constellations, all of that, your signal hop distance comes down because your satellite is closer, which means your latency and in turn your internet speed goes up. So you get like optical fiber like speeds from internet 24/7, even in some of the remotest treks you have gone.
Good. And these projects are like, what is the timeline that you're looking at?
Okay, so propulsion products are already ready and we have started onboarding commercial customers on that. And for the other two projects, I think end of 26, we are planning tech demo missions and starting to commercialize after that.
Okay, all right. Thank you so much, Yashas. That has been very insightful and thank you for your time.
Thank you. It was a pleasure.